Good afternoon and welcome. This is Will Hawkins from the ACR Journal, and thank you for registering for our R32 webinar today. We've got a number of panelists here, which I'll introduce you to in a second. Those of you who've registered, thank you very much for doing that through the r32webinar.co.uk. There will be an opportunity to ask questions to the panelists, which I'll talk about later on. But in the meantime, in the next 40 minutes, we're going to talk to you about R32 refrigerant, in terms of the refrigerant, the kit, and the tools around it to help you understand and prepare for R32 refrigerant. So the next thing I'm going to do, I'm Will Hawkins, from the editor of the ACR Journal, and I've got three experts, industry experts here to help you out, and I'll introduce them now. They are going to be speaking in this order, and firstly there's John Ormerod, who's the Managing Director of AGAS, who's the first up. Then there's Martin Ives from Fujitsu. In fact, that's the wrong way around. That should be Scott Davis, who's going to be on next, from JAVAC, and then it'll be followed by Martin Ives. So without further ado, I'm going to hand over right now to John Ormerod, who's going to explain to you about a refrigerant R32 and the ins and outs of that for the next 10 minutes.
Right, thank you, Will. I'm going to talk about R32 from a gas supplier's perspective, and the other two panelists will talk about it from an equipment perspective and from an air conditioning product perspective. I guess the first question on everybody's mind is why yet another refrigerant? Those of you that have studied the F-gas regulation in detail would have spotted this little piece under the equipment bans table right at the bottom, where refrigerants with a GWP above 150 will be banned in small split air conditioners from 2025. So this gives a problem for most equipment at the moment, which is 410A. 410A has a GWP of 2088, which puts it well above that limit. If we look at R32 in a little more detail, the first thing to point out is it is a very low GWP refrigerant. It is a GWP of 675, which puts it at about a third of the level of R410A. From an equipment supplier perspective, Fujitsu and many of the other air conditioning manufacturers, R32 is their preferred replacement for 410A. There are a number of reasons for this. It uses very similar technology to 410A. In fact, those of you that are familiar with 410A in a bit more detail will know that R32 makes up 50% of 410A. R32 on its own also provides improved cooling capacity and is more energy efficient than R410A. If we move on to the physical properties of R32, it ticks a lot of the boxes that we would look for in a typical refrigerant. It's non-toxic, it's got excellent thermal properties. The pressures are very similar to 410A, slightly higher, but from an engineer's perspective, if you're using analog gauges, you're barely going to spot the difference. R32 has quite a high volumetric capacity, which means it's very efficient at cooling. That means smaller compressors, smaller heat exchangers, and smaller pipe sizes. It's also got a fairly low boiling point of around -52 degrees Celsius. This means we will probably see it in refrigeration applications in time, because it is quite a useful refrigerant for low temperature work. It's odorless as well. Probably the only negative issue with R32 is this issue of flammability. It's mildly flammable. Now, if we talk about flammability in a little bit more detail, flammability is typically viewed by legislation as being black or white. There's sort of no grey area in between. And R32 really does fit into a bit of a grey area. If we look at all the legislation that surrounds flammability, there are a few areas that you need to be aware of. Firstly, for transport purposes, R32 is viewed as flammable. There's no it's not distinguished between how flammable it is sorry, let me start that again. Mild flammability is not a category under transport legislation. It's either flammable or it's not. So R32 will be classified as class 2.1, and under ADR you'll have to treat it as flammable in much the same way you do for propane and propylene. When it comes to the design and construction of refrigeration systems, the EN 378 regulation covers, amongst other things, the maximum charge that can go into particular pieces of equipment. And here it's treated slightly differently because the lower flammability limit comes into play. I'll talk a little bit more and use a specific example under EN 378 to show you the difference in charge sizes that you would have using R32 versus using a typical hydrocarbon refrigerant like propane. The final bit of legislation to be aware of is the Dangerous Substances and Explosive Atmospheres Regulation, otherwise known as DASIR. This really covers the issue of flammable atmospheres that arise from using flammable substances. And in principle, it aims to ensure that ignition sources are controlled and that flammable atmospheres are avoided in the regular routine of work. Now, how easy is R32 to ignite? Well, there are a number of factors to consider here. The first is the flammability limits in air. R32 has a fairly broad flammability range of between 14 and 31%. But the fact that the lower flammability limit is as high as 14% in air means that you need enormous leaks to actually be able to produce a mixture which is capable of being ignited. The next factor is the amount of energy required to get a flammable mixture going. R32 needs considerable energy to get it going, and typically a naked flame is around the minimum that is required. Small sparks, static things like that are generally not sufficient in energy to get R32 going. R32 mixed with air also has a fairly low burning velocity. This is how quickly the flame would propagate. And it's pretty slow, and that makes ignition and then flame propagation fairly difficult, but not impossible, of course. If you compare it to propane and some of the other hydrocarbons, it's clear that R32 has significantly lower risks associated with it. However, this doesn't mean you can ignore your obligations under DASIR. You need to appropriately risk assess doing any work on R32 systems and ensure then there's no venting of the refrigerant, that there are no sources of ignition that might cause problems, and that you use appropriate equipment. None of this is actually new because venting has been banned in the refrigeration industry for many years. Controlling sources of ignition is probably fairly new, but for those who've worked with hydrocarbons, they should be familiar with those already. Moving on to EN 378, I've got a little example here of how EN 378 restricts the application of flammable refrigerants according to the lower flammability limit and the volume of the room. I've got an example here where a cassette is utilized in a room which is 9 meters by 5.5 meters. And the chart at the bottom gives you the comparison between the maximum charge size you could have if you're using R32 versus the maximum charge size you could use using propane. And you can see there's quite a difference there. Now, 8.8 kilograms in a room that size would be a fairly large air conditioning unit, probably grossly oversized for the room. But you could end up with a fairly large charge size and remain within a safe range. Propane, on the other hand, you'd be limited to a very, very small charge size because its flammability limit is significantly lower than R32. And this means you're probably not going to be able to put enough equipment containing propane in there to cool the room adequately. If I move on to the cylinders, R32 cylinders are going to look slightly different to regular refrigerant cylinders. This is really because for transport purposes, the gas is classified as flammable. So they are red top cylinders. We've also changed the valve outlet to a left-hand threaded valve. This is to distinguish between it and non-flammable refrigerants. This also means that adapters will need to be used if you are using common refrigeration hoses which have a right-hand thread. We'll have a range of sizes available from fairly small right up to large cylinders. And of course, they'll be red top so that you can easily recognize that they are flammable. Best practices are required when using R32. Good quality brazed joints. Really, this goes without saying. You want to try and prevent leaks arising. Purge with OFN whilst brazing. This is because, one, you don't want oxidation inside your copper pipes, but also if you don't purge and a pipe is full of R32, you run additional risks of causing a fire. Leak prevention and detection. If the system doesn't leak, you don't have a problem. I think that it goes without saying. That applies to pretty much every refrigeration or air conditioning system. Use flammable recovery or receiver cylinders. Really, this is again best practice. It's best not to mix refrigerants in recovery cylinders. And of course, use appropriate tools with R32. They are slightly different in some cases, and Scott will talk about that in a few minutes. To summarize then, R32 should prove no more difficult to handle than R410A for most engineers. But however, you need to be aware of some different challenges, but these risks are fairly easily managed, provided you follow good refrigeration practice. I think R32 is going to be good grounding for many, as many new low GWP refrigerants are set to come onto the market, particularly for refrigeration usage. And if engineers have a good grounding in mildly flammable refrigerants, then they'll be well positioned to make this change. I guess the final point on that is keep up to date with industry developments. EN 378, for instance, is being amended at the moment, and that is really to bring it up to date with changes in with the adding of mildly flammable refrigerants to the industry. It is going to take into account, hopefully, A2L refrigerants like R32. The final point I've got is look out for this logo, R32 Ready. This will point you towards equipment and tools that are suitably designed for R32. Right, that's all I have from my side. I'm going to pass over to Scott Davies from JAVAC, who will talk to you a little more about equipment and tools for R32.
Thank you, John. So for the next 10 minutes, I'll be taking you through the information you'll need to make sure that you're safe when recovering, evacuating and leak testing. This information will be based on the steps we at JAVAC have taken and the technology we've used in our equipment to ensure complete safety. So I'll start with the Altima A2L refrigerant recovery unit. Firstly, and possibly the most important, is how to recover R32. We've designed the Altima A2L to offer the most spark-proof recovery unit possible to suit R32. Our main objective was to ensure that all electrical components, which are switch-based, were sealed. This was achieved by installing ignition protected on and off and circuit breaker switches rated to UL 1500. Another issue which we addressed was that on standard refrigerant recovery units, kettle leads have always been the standard. These type of power cords could easily spark when plugged in and out, so we have hardwired the lead with a 5-meter power cable. We'd strongly suggest that when purchasing a recovery unit for R32 that you do look to see that it will be hardwired, as this could potentially be the easiest point for sparks or electrical flashes to occur. To remove dormant refrigerant, we've also equipped the Altima A2L with a higher speed fan. This will increase the airflow and also assist with the higher capacity condenser. The Altima A2L has a twin-head compressor for larger capacity recovery rates, which is 216 kilograms of liquid per hour, 30 kilograms of vapor per hour, and with an impressive push-pull performance of 660 kilograms of liquid per hour. The Altima A2L is also compatible with all standard refrigerants, The hoses to be used can also be standard refrigerant hoses. This unit has already been on sale and in use in Australia for well over a year and has performed very efficiently and safely on R32. A side note which John previously mentioned was that when recovering refrigerant, the appropriate recovery and receiver cylinders with a left-hand thread should be used. These cylinders are available through Agas and standard cylinders aren't appropriate. So next we'll move on to vacuum pumps. So the Bulldog vacuum pump has been 32. In the design period, we took on board that it would require the same spark-proof switch and hardwired lead as the Altima, and this is exactly what we installed. As we've been manufacturing vacuum pumps for over 40 years, we used our manufacturing and testing facilities in Melbourne to produce a mist-free vacuum pump. Engineers will know that when evacuating, mist can occur from the vacuum pump. The Bulldog has a special to prevent any exhausted oil. The filter will in turn lower any toxicity mix from any other sources of oil or refrigerants. The Bulldog is also fitted with a solenoid valve to prevent loss of vacuum, say if power was to be lost on a site. The valve also prevents any oil backstreaming. The specifications of the pump are designed towards large split systems and all the way up to multi-VRV, VRF size systems. The Bulldog is 6 CFM, has a displacement of 156 litres a minute, and a fantastic ultimate vacuum of 1.5 micron. We have connections of quarter flare and 3/8 flare on the inlet of the pump, which is just generally the standard. The complete weight of the pump is 12.5 kilograms. When evacuating, we would also strongly suggest that the system is purged with OFN before evacuation. This is just to rid the system of any dormant gas. This would avoid any unnecessary compression of the refrigerant. To measure the vacuum, we would also suggest using an analog torr gauge such as a JAVAC CR2 40 analog torr gauge. We suggest this as the analog gauge has overpressure valves in case of contact with the refrigerant. The analog gauges can generally also be dismantled and cleaned of all contaminants where any oil or debris to reside inside of the gauge. Again, standard hoses can be used for evacuation. So leak detection. So we have the GasMit, and the JAVAC GasMit has been the best-selling ATEX approved spark-proof leak detector for the past 5 years. The GasMit has previously been used with popular A-gas detection product tracer gas, as well as many common industry flammable hydrocarbons, for example R600 and R290. The GasMit has been specifically designed towards flammable refrigerants market, with R32 now in the industry. The GasMit is ready and waiting. The ATEX approval on the GasMit covers EN 60079 and EN 60079-15. This makes the GasMit compliant to use in explosive gas atmospheres. So for using leak detectors for R32 and hydrocarbons, we highly recommend that ATEX approval should always be the standard. The GasMit is classified at UL 913 Class 1, which is the standard for intrinsically safe apparatus. As with all JAVAC leak detectors, they are highly sensitive to the refrigerants which the sensors are set to. And under F-gas regulations, the standard for leak detectors detection rate should always be under 5 grams per year. The GasMit will easily detect to the equivalent of 1 gram per year. So this detection rate makes the GasMit very accurate when pinpointing the smallest of leaks on any R32 systems. The features of the GasMit include the sensitivity slide button, which can increase and decrease the sensitivity. This gives the user the ability to increase the sensitivity to maximum when trying to locate the hard-to-find leaks. The sensor on the GasMit is a replaceable part and will generally, on everyday use, last around 2.5 to 3 years. The GasMit can detect standard refrigerants with ease. However, we would suggest that the TechMit and the D-Tech Select are used for all standard refrigerants, as the sensors are highly tuned specifically for this purpose. So next we're looking at refrigerant manifolds. So with manifolds for R32, there isn't a great deal that's going to change. The scale on the manifold will change, and the Refco dual scale manifolds will have R32 and R410A as standard. These will also read the pressure in bar and PSI. As with all manifolds, they'll come in the Refco green carry case and will come with 36-inch hose set of red, yellow and blue. The red and blue hose will be 1/4 to 5/16, and the yellow will be 1/4 to 1/4. The AC system connections will be 5/16, which is the same as R410A. So all hoses come standard with valve depressors also, and the sight glass will be standard on all R32 Refco manifolds. We would strongly suggest that all refrigerant manifolds are used for only the refrigerants which are stated on the gauge heads. Pressure testing with manifolds is a bit of a breach of best working practices. So refrigerant manifolds featuring sight glasses should really never be used with OFN. For pressure testing R32 systems, we'd suggest that an industry standard 0 to 50 bar nitrogen regulator and a PVR pressure testing manifold are used. So we'll now move on to the refrigerant scales. So for refrigerant scales, we would suggest that to eliminate any potential spark, basic battery powered scales would be suitable. The main type of scale to avoid if possible would be the 240 volt powered scales, as if cables can become trapped or split, there is a potential for sparks there. This year at JAVAC, we've brought to the market the WATEC HD wireless Bluetooth scale. This app-based scale will be better suited to use with R32, as the range of the scale to the smartphone is 30 foot. This means that when charging or recovering R32 refrigerant, a safe distance can be kept even as far away as out of the room or out of the area the condenser is located. The app is designed so that target weights can be programmed into the phone, so that when the refrigerant is reaching its target weight, an alarm will sound on your phone, and that warning will be that the target weight has been reached. At this point, the engineer can then approach the refrigerant and either change or shut off the bottle. The WATEC HD features a job log feature, so that all charged or recovered refrigerants can be logged on the app along with all other information the engineer really can wish to enter. This in turn can then be emailed to the customer or office, and the refrigerant log for that specific R32 bottle can be tracked and logged. Another great feature of the WATEC HD is that it is IPX4 splash proof rated, meaning rainwater, bottle condensation cannot ingress really into the connections. As there is no handpiece attached to the scale, this also prolongs the life of the scale, and this has generally been the first point of rainwater ingress. As John also mentioned, that for R32 bottles, AGAS has specified a different bottle adapter from the standard refrigerant bottles. The bottle adapter for this has been tested and approved by AGAS on R32 bottles. These adapters are a female left-hand thread with a 1/4 male flare connection. The specified gasket is a white Teflon gasket, and these bottle fittings are now available at wholesaler level. So that really sums up the complete range available from JAVAC. If you need any further information or any of the mentioned products, please visit our website or also call me directly, and I'll be happy to assist with all questions. So thank you very much for listening. I'll now pass you over to Martin Ives of Fujitsu Journal.
Thank you, Scott. I'd like to introduce you to Fujitsu's next generation of R32 systems. Now, every so often, we are faced with challenges of new refrigerants. High pressures, blends, and flammability are just a few changes we are becoming more familiar with. I'm sure you'll remember when we're looking at phasing out R22, the likes of 407, discussions of fractionalization, and glides were big discussions at the time, and then the higher operating pressures of 410A. But yet 410A has become the standard refrigerant in most air conditioning units. R32 is the latest refrigerant to send shockwaves through our industry. I'm not sure, but if you've been using 410A, R32 actually makes up 50% of 410A. And R32 is a single component refrigerant, making it nice and easy to use and recover. R32 was first introduced into domestic air conditioners in 2012. In June 2011, under the Ministry of Economy, Trade and Industry of Japan, Fujitsu and other leading manufacturers agreed to help introduce R32 technology into Indonesia as part of the phase-out of R22. Since R32's launch, the global market has adapted quickly, with the likes of Japan, Indonesia and Australia now having in excess of 50 R32 systems registered in each of their markets. Success in Australia and New Zealand since 2013. Since launching in 2013, Fujitsu Australia have sold over 250,000 R32 systems and trained approximately 3,000 customers on R32 products. There were challenges to overcome when the product was first launched in the market, with methods and refrigerant availability. Fujitsu's focus is now with products up to 14 kilowatts now being available. R32 has a higher cooling capacity than R410A, increasing the efficiency. We can see here the efficiency of a typical R410A Fujitsu product and an R32 in cooling, and again in heating. We can see an increase in efficiency by approximately 20% when we compare the two. The greater cooling capacity of R32 reduces charging volumes by approximately 15% compared to 410A. The capacity of R32 is smaller than 410A. Therefore, as the GWP is measured in kilograms, the environmental impact from the refrigerant system is less than suggested by the GWP. Longer pipe runs without additional refrigerant. A typical R410A 2.5 kilowatt Fujitsu system has a pre-charged amount of 850 grams, achieving a maximum pipe length of 15 meters. To achieve a pipe length of 20 meters, an additional 100 grams of R410A must be added, with a total volume of 950 grams. If we look at the same capacity system on R32, the system has a pre-charged amount of 850 grams and achieves a maximum pipe length of 20 meters. Therefore, there's no additional refrigerant required, and yet we get a longer pipe run. Reduced physical size of the system and the pipe diameter. Now, if we look back at R22 systems, we see them nowadays, they're very big, bulky systems, and we can see the reduction in pipe sizes when we compare them to the likes of R410A systems. And again, with R32, due to the greater cooling capacity, future R32 systems can be considered for the reduction of the physical size of the system and also the pipe diameter. R32 and R410A have similar characteristics, meaning the product is almost identical. It's the same high density multipath heat exchanger, high efficiency DC fan motor in the condenser, large heat exchanger in the indoor unit, high efficiency DC for the indoor unit, DC twin rotary compressor. So therefore, the R32 product is almost the same as the 410. We may have an efficient product looking at 410 or R32 systems, but if we're not controlled, we may as well just leave the system running and then forget about the running costs of the product. But simply looking at the likes of PIR sensors, motion detection, we can reduce the running costs of the system, making them even more efficient. Or we can look at hotel key card entry systems by simply turning on and off the system or reducing their set point to make them more efficient when they're not in operation. System design. 3 items design engineers considered for fire prevention. Construction that makes refrigerant stagnation minimized. Electrical parts have been designed to make ignition difficult, non-spark components. Chassis design makes fire propagation difficult, all reducing the risk of fire. The compressor itself is Fujitsu's high efficiency DC inverted compressor using POE oil similar to 410A. So unlike R22 using mineral oil, R32 uses POE oil similar to 410. However, due to the increased acidity and also the higher discharge temperature, the grade of the oil is slightly different to 410A. If R32 is ignited, the byproduct that is released is hydrogen fluoride, which is toxic. The same danger exists with 410A or any fluorinated refrigerant. The way to prevent this product from being formed and released is to use oxygen-free nitrogen, OFN, at all times when brazing. Now, just reminding you of the flammability issue of R32. R32, even if ignited, the flame propagation speed is slower than the speed of a person walking. We can see there the speed of a person running at 2.5 miles per hour, but the combustion speed of R32 is 0.1 miles an hour, meaning the risk of fire spreading is very low. The tightening of flare nuts is not only important with R32, but any refrigerant that's contained in the system. Therefore, it's important to use a specified tightening torque, otherwise the flare nut could crack or leak over time. Like R410A, existing pipework can be reused. As long as the pipework is free from defects and contamination, insulated on both lines, and the pipe wall thickness complies to our guidelines, you can consider reusing the R22 pipework. However, capacity and efficiencies can be reduced when the standard pipe sizes are not used. Now the big question, when? When will we see the Fujitsu R32 products in our market? Firstly, we need to educate and inform the end users and the contractors the benefits of R32, preparing them for the launch of the R32 product. So they need to be aware of the lower GWP and the higher efficiency of the product. Then we need to look to train the contractors and the service engineers, making them comfortable with the different tools they're using, recovery machines and vacuum pumps, giving them time to purchase this equipment, and also making them confident to work on the product. We will be introducing R32 training courses later this year. And then finally, we see the product arriving to our market. Fujitsu are expected to announce products later this year, early next year. I'd like to thank you for your time, and I will pass you back to Will.
Thank you, Martin. That was great. That draws our webinar today on R32 to a conclusion. I expect a number of you will have questions, so we left put on our r32webinar.co.uk website. There's a form there. If you want to send us any questions, the ACR Journal team will gather that and send it out amongst the 3 speakers today. So we'll get back answers to you on any questions you have. In the meantime, we'll also put up a recording of this webinar onto the R32 webinar website, along with slides and any other useful materials which will help you with understanding R32 and help you get ready for this refrigerant coming to the UK. So that's all from me now, and so I want to thank John, I want to thank Scott, I want to thank Martin for their contribution, and also finally to thank you for your attendance to this webinar, and we very much look forward to hearing from you, all your questions on the r32webinar.co.uk website. So that's it from us for the time being. So thank you again for taking the time out of your busy days and listening to us, and we'll be back in touch with you very soon. Thank you.